Now?
Yeah.
How about now?
Is there a reason why all the clamps are there before you do your...
This is a heat sealer. It may be a little difficult to see, but there's Teflon fabric here, and underneath that there's high temperature silicon. On top of it there's Teflon fabric, and there's a nichrome wire that goes from here down to here. Now when that nichrome wire has electricity passed through it, it heats up. That means that it'll melt thermoplastic from here to here. And there's a spring down at the end here which will keep it under tension. When it gets hot, it expands. The spring contracts. It keeps under tension. And this is made for, you can make biogas bags with it. You can also make biogas digesters, plastic digesters for tropical climates. It's also designed so that you can seal a little bit and then pull the bag this direction, filling up this space, and then seal a little bit more. Some people might ask, well, how come you didn't make it longer? I have to say this is the only length I could get nichrome wire in that I know of. And this whole thing is designed to come apart. For the most part, it fits into my carry-on luggage. Almost nothing is more than 2 feet except this, which I carry around in a big PVC pipe. But it's actually carry-on.
You brought that to Brooklyn when we were there.
Yeah.
And you said that there's a rod here that looks somewhat like that. That you said is Teflon.
Yes.
All right, that's a Teflon rod. And the function...
Because you can't have the nichrome wire resting on aluminum. So it has to rest on something. This happens to be a good insulator. And Teflon will survive 700 degrees before it begins to melt. It doesn't burn. It obviously, even if plastic melts onto it, it's Teflon, so nothing
You say
will
700
stick.
Celsius or Fahrenheit?
Fahrenheit, as far as I know, as far as I recall, if memory serves.
So you're saying it doesn't stick.
Right. And so seal, slide, seal, slide. I once took this to New York. I was in Ithaca and had not packed my my Teflon fabric. So when I built it, it was sort of raw. And what I did was I took newspaper and got it wet and put it on there and sealed it, and that worked just fine.
Really?
Yeah.
In place of the Teflon fabric.
Uh-huh.
So this is the Teflon fabric we're looking at here.
Right.
And here, wrapped around. In this case, now, Andre, here you said you don't have Teflon.
That's high-temperature silicon. It's
High-temperature
sort of an odd-shaped piece of silicon which fits into this guy really nicely and has this flat top.
And it comes in that shape?
Yeah.
Comes
And you
as
can
these
get
rods?
it from the same place that I got the rest of this, and unfortunately I don't remember the URL.
It plugs into this metal piece here. Is that the way it came?
It slides.
So it came with that nipple.
The metal piece is something that my son found for me, and it just happened to all fit together.
So how? But what about this little nipple here that fits in? Was that the way this came?
That's the way it slides.
The silicon came like that.
This aluminum is like that,
right?
And the silicon has that kind of this.
It does have that keel
Yes.
kind of thing.
And so it's got exactly. So slide the silicon in with the Teflon fabric sort of pulled down on it, and it makes it a very nice pad for resting on.
What does that usually come for? Why the keel in there? What's this usually used for?
You know, honestly, I don't know, because these are all repurposed parts, which are made for something else, but they work for this.
And where would you find such silicone?
I wish I could remember the URL, but
Okay.
you're going to have to post it later. Or paste it
Silicone
on
rod
this.
or something?
It's somebody's name, if memory serves, but in any case.
And you've put this square wooden dowel in so that you can have something to screw the nichrome wire.
Which is insulated, right?
But by the Teflon.
The nichrome has to be insulated from the aluminum.
Yeah.
And so it rides up over the Teflon, a little thinner than this piece here.
Okay.
And then with the fabric
Oh, yeah,
in
I see.
place.
Okay.
See, again, because I created a slot so that I could stick the Teflon fabric up in there.
So a great way to make a biogas bag to heat seal, as
Right
opposed
now.
to
Yeah,
the.
this works very well. I've used it. This has made hundreds of bag digesters.
Nice.
Nice. And we think it might be useful on PVC bag.
It's possible. Like I said, I'm not 100% certain that a PVC bag is thermoplastic. If thermoplastic, it'll melt together, and this will work fine.
Now, what is does it have a maximum, the temperature it's getting to, you said was 700. You can't dial that.
That's the melting temperature of the Teflon. You
Okay.
never get up that high. You're just trying to melt the plastic. And
So does it
doesn't
have a
to-
set temperature?
So
Is
it's
it micron wire?
160, one something. I don't know what it is, but it's not that high.
But you don't change it.
It depends on the voltage. You can change it with the device that two different devices that my son designed for me.
Okay, by regulating the voltage
Yeah,
and
it's
current.
basically and if somebody is interested and they send me $1,000, I'll send them to the circuit. Maybe cheaper than 1,000.
Okay, so that's the heat welder machine.
You can post the circuit. I can send you the circuit. You
Okay.
can post it.
Do you want to tell us about how we're doing with
Well,
this?
so this is a different kind of digester. The bag digester is meant for a tropical climate because it doesn't have any insulation, there's no way to heat it, there's no agitation. It's meant to be extremely low cost in order to have a beneficial impact on poverty. But this is an insulated digester. The key point here is that this polystyrene, the insulator, is the container. And on the Complete Biogas Handbook website, you can see a little tiny video which gives you this idea. You can see all these pieces of insulation flying together to make a box, just like this. Now in this case, this is the front side, and we haven't glued it in, so we can pull it off to show you what's inside. And what's inside is these hex units. These are the heat exchange units, so I call them hex units. This is where the effluent pipe comes out, and this is the axis for the agitator, which you can kind of see moving around in there. So if we take this off, take out the hex units. And we can take out the agitator. All right, this is kind of, thank you, just hold on to the axis. Appreciate it. All right, this fills with biogas, each one of these cups, and when it fills, it lifts and spills. And it's made here of 3 pieces of wood on this side, 3 on this side. These cups are made from 4-inch PVC, ASTM 2729 cut in half. And one side is held to the other with a nylon string. There's a certain tone
That song.
that I like. That one's too low. That's a good one. That's a good one. That one's a little low, and so on. But it holds one side to the other in those routed grooves, and this is my agitator. It's very light. It costs $24 for the 1x4s and the pipe and the nylon.
$24 paddle wheel.
And then you can see the back hex panel and this hex panel. Down at the bottom here, this L-shaped pipe is a bubbler. It bubbles biogas through these slots here up into the agitator to move it. So if you want to, you can move it deliberately by pushing gas back into the digester, or the evolution of biogas should also rotate this, although very slowly. So it's a self-agitating digester.
That's a good point that wasn't clear in the past couple of days, that since it's bubbling a lot from the sludge layer at the bottom, that this passively could turn with no extra effort.
Yeah, and I don't know what the rate of rotation will be, depending on the rate of digestion, what I'm feeding it, and so on. It could be as low as 3 RPD, revolutions per day. It might be higher. I don't know. But we'll find out because I'm going to instrument it. I'll have a little Hall effect switch right here. And as the agitator comes by, it'll brush the switch. And only one of the arms will have a magnet on it. And it'll tell me, it'll pulse and say, well, I've gone around once. Pulse, I've gone around once. Pulse, and so on.
Very good. And now we're working on the sump for the heater.
Right now.
And that's what we worked on today.
So you've got the float valve which will ensure that if this falls all the way down, i.e. it's empty, then it'll trigger a Hall effect and I'll get an alarm. This guy here, this round guy here, has a pump at the end which forces water in. There's an aluminum, like a coffee cup heater on the inside. The water flows this direction and it flows out the back. You can see there the pipe in the back that flows into the hex units, the heat exchange units. And God willing, that'll be
through this hole here. Mm-hmm. And that's where that's going to pump into, and then the return from the heat exchanger just falls in here. And this has a nice, convenient garden hose thread, so you can keep a garden hose that is turned on, and as this will seal it like that, and then when it drops, it'll open up. So that's nice. OJ would love to have that for his water trough. All right, and so that's that, and then there's going to be a piece put on here, right?
On the front, uh-huh.
Where is that piece? That's what you guys just cut right there.
Yeah, well, we're on the top right now.
Oh, the top, okay. And of course, the marvelous thing about this is that you simply use foam spray to glue these panels together. And that polyurethane foam creates a watertight seal, and then with a wood frame on the inside and the outside, you're able to hold the pressure of the water.
Right. And there are plenty of things you can use to seal polystyrene to polystyrene. This foam is called great stuff. It's also terrible stuff. Great stuff is terrible stuff because it gets on your clothes, it's very messy, and it really will ruin almost anything that you have. But it will weld polystyrene to polystyrene, and that weld will be stronger than the polystyrene itself. Usually if it breaks because on an oxidized layer or something like that. Or if there is no oxidation on the polystyrene, it will break into the polystyrene rather than breaking itself. So it forms a very strong weld. And likewise, it has the advantage, unlike caulk, of expanding. So you put it on, you press it against, and it continues to expand, filling all the holes and so on. And that's, I think, a considerable advantage over caulk. It tends, likewise, to be less expensive than caulk, particularly if you can kind of queue up lots and lots of foaming that you need to do, and then use one can up.
Right.
Because if you have to leave it around, you may not be able to use it again. The second, third, fourth time, it won't work for you.
Well, shoot, then let's say goodbye to our audience and let's finish her up. That'd be cool.
Goodbye to our
audience.
Goodbye. Goodbye.
Goodbye to audience.
Bye.
Thanks for watching, everybody, and we will keep you updated on the progress of what may be the least expensive, most effective, and commercially viable option for small biogas that we've seen yet on this particular planet. We don't know about the other ones. But
I might be able to tell you.
Literature on that.
look on the CD. All right, so remember, folks, while we may be professionals, please do try this at home.